Hello everyone, welcome to Data Discovery. At this video, we are going to come across the standard normal distribution. Like previous video, we have discussed related to a normal distribution. Now, in the standardized form of the normal distribution that we are going to discuss at this video. Previously, in my normal distribution video itself, I hope you have gone through it. In that only, I have given small tips that over there in the standard normal distribution, the mean is will be equal to 0 and standard deviation is 1. It's nothing but already inbuilt values, but in normal distribution the mean and standard deviation that we need to calculate it. Okay, so what is the standard normal distribution and how the standard normal distribution actually looks like, and the z score. So actually the z score comes into the picture, that why the z score comes into the picture, that we will be understanding in this video. And then most important code, all in just one video itself. So let's get started. So the standard normal distribution, it's also called as a standardized form of the normal distribution, with mean is equal to 0 and standard deviation is equal to 1. Okay, this standardizing a normal distribution allows us to compare different distribution within each other data, and to calculate the probabilities using a standardizing tables. Like for example, okay, I'm having one distribution. This, take it as the probability distribution, any probability values in my y-axis, and in my x-axis I'm having some of the mean. Like we'll take it as 68, 70, 72, something like any values. I've just took it randomly. So randomly, this is how normal distribution looks like, right? But the distribution will be something like this, right? 67, 62, 40. Based on that I just built it. Okay, the x values are not at all important, but while once we are converted into a standard normal distribution, this x values will be most important. So over here I'm just getting one normal distribution. Okay, my symmetry is there, my mean is equal to median is equal to mode. If it is equal, then it's set to be as a normal distribution. By QQ plot you can understand that whether it's following a normal distribution or not. So there are various kind of the thing to prove that whether it's following a normal distribution or not. Now this normal distribution data, okay, I don't know what is mean, I don't know what is standard deviation. By calculating it we can find it. Okay, now while converting into a standard normal distribution, the z score comes into the picture. The z score comes to the picture while converting into a standard normal distribution. When we are converting into a normal distribution to SNT, that is nothing but standard normal distribution, where my mean is equal to 0 and sigma, that is nothing but my standard deviation, is equal to 1. So at that moment, like over here, the mean, okay, this mean is equal to 0 and sigma is equal to 1, 1, 2, 3, minus 1, minus 2, minus 3. So when the normal distribution converted to a standard normal distribution, the z score comes into the picture. So what is this formula of z score? Z score formula is x minus mu by sigma. Okay, so for understanding the z score, I will be giving some of the concept related to a z table also. So once we are understanding with it, we can easily understand the z score. So z score, the z, whatever the values that we will be getting, it just tells us the area underneath of the normal distribution curve to the left of the z score. Like for example, if my data point around 71 data, okay, 71 is lying over here. So if the person marks is my x-axis, so if I need to find how much number of how much the area or percentage of the people lies, this the people scored more than 71, if I need to find it, then by using a z score, by using a z table, I can easily find it. Okay, we can take one formula. So based on that, we can do it. So this is nothing but the z score formula. It's nothing but x minus mu by normal distribution. So I'll just go to the Google, and then I'll show the Z table how actually it looks like, and based on that I will be doing a calculation, and then we will be plotting it. One example. So based on that, I'll just plot how the standard normal distribution looks like, and by using a z-score that we are finding the percentage of it. So like previously that I have given the example, same, almost same, it's similar type of the example only. Okay, we are using the same example and we are just trying to do it. Okay, now here is the question. So the question says that the test score of the student in a class test has a mean of 70. Mean is nothing but mu is equal to 70. It's already given. And standard deviation as 12. Okay. What is the probable percentage of the students scored more than 85? It's nothing but my x value. This is what I need to find it. Okay. Let's take it as that we need to find it. This is given and this we need to find it. Okay. Now to calculate the z score formula, what will be my formula? X minus mu by sigma. So over here the standard deviation is 12 is given. Okay, so based on that only we'll just try to plot this standard normal distribution. This will be all my probability values. Anyways, I'm not interested at all now. And over here the mu value, it's already given, it's at 70. Okay, since the standard deviation is 12, so based on that the 12 jump, 70 plus 12, okay, you will be getting as 82. And then 94 plus 12, just add 12, 106. And over here just subtract the 12 values from the 70, so you will be getting as 58, 46 and 34. Okay, so based on that you have built the standard normal distribution. Now if you will undertake the values, okay, if you choose by using a z table, if you will find the values, then you will be getting a 0, 1, 2, 3, and over here -1, -2, -3. Okay, by the mean, if you will subtract the standard deviation, the particular value, you will be getting this. Okay, let's try it once. Okay, first let's take the value as 82. My x value is 82, my mean is 70, and my standard deviation is 12. So based on that you will be getting as 12. So you will be getting as 1. So it's nothing but one standard deviation away from the mean, right? And if take the other value and also check it. Take the value as 94 and just check it. You will be getting this value. Okay, so this how the standard normal distribution is constructed. So based on that you will be getting a plot, right? So what the question says that, let's move on to it. Okay, we need a percentage. What is the probable percentage of the students scored more than 85? It's nothing but it's lying around 85. First we'll just plot it. The percentage of this, we need to find it in the percentage format of the student scored more than 85. It means this part we need to find it, right? So how we need to find it? Let's get started. So before that I'll just love this value. And for this the z table will be most important. I will be showing it over here, even you can try it also. Okay, here is the z table for it. Okay, whatever the values has been inserted over here, okay, the shaded part, it's been showing over here. Like for example over here we need to find this white part. So for that you need to subtract 1 minus the particular area. But if the values, if the percentage is being asked that what's the value less than 85, then the same value that you can take it. Okay, I will be showing it over here. Okay, as per the question that they have said, around 85 percentage, around 85 percentage, right? So for that we need to calculate the z score. Okay, z score is nothing but x minus mu by sigma. So over here what we need to find, 85, x is equal to 85, this is what we need to find, right? X is equal to 85 minus 70 by 12. So if you will finding it, you will be getting as 15 by 12. It's nothing but around 1.0 something like that. Okay, it's around 1.25. They have mentioned over here 1.25. So it's nothing but 1.25. 15 by 12 is equal to 1.25. So based on that, we need to, this is my z score value. So this z score value, that whatever you are having over here, just put it in a z table. So here is my z table. So my 1.25 lies something like over here, 1.2 and 5. It's around 0.89 by 40, 0.8944, right? So it's around 0.8944. It's nothing but 89 percentage. So what is that 89 percentage? 89 percentage is this part. If the values is less than 85, if the score more less than 85, then the value will be 89 percentage. But my question is different, score more than 85. So for that purpose, I need to subtract this value by 1. So whatever the value that you will be getting over here, it's nothing but this part. Okay, because in the plot itself they have mentioned that whatever the entry that you are getting from the table, it's of this shaded part. If you need to find this white shaded part, then you need to subtract this one minus the particular part that you are getting from it. So we got around 89.8944. So you need to subtract 1 minus 89.44. So this is how we need to find it. Here you have got around 10.56 percentage. Yeah, it's nothing but subtracting 1 minus 89. But over here they have already converted into percentage, so for that purpose they have difference it from the 100. So it's up to us. You can subtract from 1 minus 0.8944 or 100 minus 89.44 percentage. So anyway, this is how we need to calculate this Z score, the Z table, and the standard deviation comes into the picture. How the normal distribution data that we have converted into standard normal distribution, and by using a Z score value, we have found the area of it. If it is less than or if it is more, then how to find it? That by using the Z score, by using standard normal distribution, that we have found it. Let's move to the code. Here is the code for the standard normal distribution. So this is the picture of the normal distribution, but in standard normal distribution, what you need to do, the mean is equal to 0. Wherever the mean value is there, just put it as 0 and sigma is equal to 1. So and then after you will be getting one equation. So that is nothing but the standard normal distribution. So the standard normal distribution, the formula is very simple. It's nothing but 1 by root 2 pi, where the sigma is equal to 1. E raised to minus 1 by 2x square. So this is how the standard normal distribution formula actually happens. Okay, the plot will be almost similar to the normal distribution that we have seen. Okay, here the mean and standard deviation that have fixed values, and then after you will be getting a plot. I hope the plot will be almost same to the normal distribution itself. And then after the application of this z score and standardization, okay, this normal distribution, z score, standardization comes into the data science each and every project, we can say. While analyzing the data, we need to understand all these z score value, like calculating a z score, the standard score, to a standardized data, making it easier to compare data from different source or population. Z-score represents the number of standard deviation a data point is away from the mean, and can be used to assess how unusual or typical a data point is within a distribution. For the hypothesis testing, definitely there are many tests: Z test, T test, one sample test, F test. There are n number of tests that we can say. So, but there are also the Z score value, the standardized value will be needed to it. So we will be coming across the hypothesis testing each and every part. I hope this video find it out so useful as I have came across in this video related to standard number distribution. But in my channel, I will be coming across more and more related to data science stream. If this channel finds it out so useful, do like, share, and subscribe to the Data Discovery. Thank you.